Hello and welcome to Algebra Unit 1-2, Lesson 4. Today's objective is scholars will understand how changes to a function can transform the function. So we're looking at transformations of functions. So first of all, how can functions be transformed? So they can be translated, otherwise slid, either vertically or horizontally. A vertical translation occurs when we add or subtract from the output. You'll see that example over here. At the end of this equation, we just added a plus something. That is a translation of the original parent function here. If we add, it moves up. If we subtract, it moves down. Now that makes sense, right? If we're adding to our function, it's going to move it up. If we subtract, it moves it down. Horizontal translations occur when we add or subtract from the input. You'll notice over here, x was replaced with x plus k. That's adding to it. Now, if you wanted to see what this would look like normally, you could go ahead and multiply it back out and then combine your like terms. But in this case, instead of adding, moving it positive, adding moves it to the left. So when we're talking about adding or subtracting our input, it sort of goes backwards. Adding moves it left. Subtracting moves it right. So remember that for horizontal changes, it always seems backwards. Adding moves left, moves it to the negative. Subtracting moves to the right. Okay, so they can also be stretched or compressed. Again, vertically or horizontally. Picture grabbing the graph and stretching it out or pushing it down. So vertical stretches occur when we multiply the output. So here you'll see this is what multiplying the output looks like when we take the entire function and multiply it. Notice when we do a vertical stretch, the x-intercept, where we hit the x-axis down here, stays the same. Horizontal stretches occur when we multiply the input. So that is how you see here where we're just multiplying our x value, our input. And in this case, the y-intercept stays the same. So compression occurs when the scale factor is less than 1. So I should say when the absolute value of the scale factor is less than 1, it compresses it, it pushes it down. When the scale factor is greater than 1, it stretches. So when it is greater than 1, it stretches. Compresses when it's less than 1. Stretches when it's greater than 1. Okay, so let's talk about this. Looking at the equation. So things in the equation that we can change. We can change the slope. Of course, we all remember positive slopes go up from left to right and negative slopes go down from left to right. The greater the absolute value of the slope, the steeper the line. So a slope of -3 is steeper than a slope of 0.75 because we're looking at absolute values. A zero slope is a horizontal line. Remember, a slope of 0 is a horizontal line, no change. So then we can also talk about the y-intercept. It's also that can be changed. It can move the line up or down. Increases to the y-intercept move the line up, and decreases to the y-intercept move the line down. A y-intercept of 0 goes through the origin. Remember, the origin is just the point where your two axes meet. That means that my line goes through that origin. It also means that if it's linear, it is proportional. Okay? So make sure that you understand what these do. You're going to have some fun playing around with it and then do some work in Savvis. Let me know if you have any questions.